Okay, welcome to the next lecture. Here we are going to see the LCD, liquid crystal display, and 7-segment display. Let's move ahead. Liquid crystal display or the LCD. If you see, it is a combination of two type of state of matters. One is a solid and second is the liquid. The liquid crystal display, if you open up, it is consisting of many layers, and the main part is nothing but the polarized plane filters and the electrodes. That polarized play panel filters are going to decide the direction of the light to be falling on the last panel. That is what the display. Most of the smartphones nowadays are going to use the LCD display technology, but it has been now replaced by IPS display and also the AMOLED display. So those are the current improvements over the LCD. We are concentrating on the basic LCD concept. So in order to understand how the construction is there in case of the 16 by 2 LCD that we are going to use in our project. So in order to understand that, the basic part we are going to cover over here. The liquid crystal display is consisting of several layers, as it is already said. Moving ahead, we can see that it is having the polarized filter. The job of polarized filter is to polarize the light. How the polarization of light takes place, let me explain with the help of these two figures. So in first figure, you can see this is a polarization plane. It is giving vertical direction, and the last plane is also vertical direction. You can see your light is having omnidirectional waves present in that. So when you make this omnidirectional wave pass through the plane which is polarized vertically, you get only waves which are in the direction parallel to this plane, that is only vertical waves are coming out. Further, at last, if I make the same plane here, then you will be seeing the same plane is going to come out of that. But if the second plane I'm going to rotate it by 90-degree, as it is the wave is containing only the vertical polarization, and this panel, the last filter is having the horizontal polarization. Because of that 90-degree shift, this waveform will be completely blocked, and you will not be seeing any light waves coming out of this filter. Okay, so this is what when unpolarized light gets through the polarizing filter, only one plane we want to get at the output, like this as shown here. So making use of this concept, LCD designing, LCD working takes place. Let's go ahead. It is a construction of LCD. No doubt this is for the color LCD, but instead of this color part, you can see over this part that is having the red, green, and blue RGB. Instead of this, you consider it as a monochrome. If this layer is to be replaced by monochrome, then it will be the monochrome LCD. Okay, only that change will be there. It is showing a vertical cross section. This yellow part is nothing but the uh, final polarizer. Here you are going to see the characters. This is a plane which is available on 16 by 2 LCD, the green part that we generally say, it is shown here in a color part. So this is a final polarizer filter. Similarly, at the start, there is one polarizer filter also shown at the bottom. So where the light is going to fall on this polarizing filter first. Then you can see there is a transparent common electrode. Okay, this electrode, this blue color. Then it is having the thin scan lines over there. Scan lines are shown here. Then thin film resistors are there. Then it is having the liquid crystal is placed over there, and this liquid crystal is having this part. So if it is a monochrome, that will be having only one color. As it is now in this figure, it is a RGB, it is having the three color. Okay, as this is given transparent common electrode, the in same fashion the electrode is given here also. Okay, in some cases, you will see that it is going to use a glass as a substrate. The one side of the glass is rubbed with one kind of material, so static electricity get deposited on that, and it is seen that the static electricity remains over there on this glass substrate material. So like this, you get two type of polarity generated over this blue plate on this side and blue plate on this side. That's why it is called as a electrode. So two electrodes are there. Let's moving ahead. The liquid crystal molecules are going to flow along the grooves. So there, if you see the design, this is having the grooves. You can see it is not a flat surface. It is slightly going up and coming down. So some grooves are made here. So liquid crystal molecules will be something like this, shown in this figure, like in a random fashion, having orientation in random direction. So whenever they come in contact with such kind of grooves and there is an electricity, then we try to make this crystal molecules to move along the grooves. Okay, so this is an idea. There are two polarizers shown here, the top one and the bottom one. The second polarizer where the output is seen is also called as an analyzer. So unpolarized light is going to fall on this first polarizer. This polarizer is going to have the grooves in this direction shown by this horizontal line. So only the light which is in this direction is going to get through this, and you are going to get a polarized light. Okay, now when the second analyzer is having the direction, okay, the grooves is at 90 degree in this direction it is shown, which is at 90 degree to the direction of polarized light. This light is not going to make through this analyzer, and you are not going to get any light over there. That's why you see the characters on LCD in black color. So whatever character get displayed in dark black color, that is because of for that character the light is not able to come out of the display. That's why you see a dark spot, and that dark spot, and that dark spot is going to have the character displayed on it. So what happens when you are going to have this analyzer, the second analyzer in the direction of this polarizer? In that case, light will get easily pass through this, and you are going to see the light out of that. Now here it is not possible to make this analyzer move. You cannot physically move this to analyzer. Initially for getting light, you have to make analyzer in this direction. Then for getting no light, you have to make analyzer in this direction, and it is not possible for every character. So instead of that, is it possible to move the molecules, liquid crystal molecules itself? And that is possible because the state of that is liquid. So because of liquid nature, we make those molecules get into the direction of this groove, or get at in the direction of this groove. If the molecules are getting direction of these grooves, then the light will be passing through that molecules, and you will be seeing no character over the display. And if you make the molecules to get twisted in this direction, in that case light will be not able to pass through the molecules, and for that reason the dark spot will be created. So by this concept, so what happens here is that, as it is shown here, the top polarizer and the second analyzer. The top polarizer is going to have the grooves in the direction shown by A, and second polarizer is going to have the grooves in the direction shown by B. So when you don't apply any supply momentarily, if you don't give any supply, what happens is that whatever the molecules are coming from the first polarizer while transmitting through several layers, when it reaches to the last analyzer, they get itself adjusted in a direction of these grooves. So what is that? The molecules are parallel to the grooves. As a result, whatever the light carried by these molecules, that get parallel to this one, and the light get twisted. As the molecules are twisting, here concept is that the polarized light get twisted. So whatever the polarized light you get through the first polarizer, along with these molecules, as these molecules get twisted under the application of no external voltage, that's why the light also get twisted, and you are going to, at the bottom of this display where the main display part is there, you are going to see no character displayed over there. Okay, moving further, if I want to get the character to be displayed, what we do is that we apply external voltage on this between these two plates. So that is what we apply, VCC and ground. And for every character, whatever the character is sent, there is a change in voltage. So what this voltage is going to cause, this voltage is going to generate the electric field in this vertical direction. So because of this electric field, these molecules, liquid crystal molecules, get themselves arranged vertically. So whenever they reaches through several plane to the last analyzer, they do not get twisted. Now we are making the light to do not get twisted along with this untwisted LCD molecules. So whenever the light reaches to the lower analyzer, the polarization of this light is at 90 degree of the grooves of the last analyzer. As a result, light cannot pass through that, and what you are going to see that you can see the dark spot on the screen, and because of that the characters are printed on that screen. So this is the working principle of LCD. So what are different advantages of LCD? Let's see different advantages of LCD. Number one, smaller size. All the displays which are available, those are available from very small size to the bigger size. The small size are mostly used in wristwatches, thermometers, then in your mobile phones, and again the tablet, in your laptops, and the larger one are used in television displays, and the hoardings at the advertisement at different corner of your squares on the road. So those are available from smaller size to the larger size. The most popular are the smaller size, so it is easy to carry. If you compare the LCD with LED, LCD consumes very low power, so it is having very low power consumption. As it is smaller in size, it has a lightweight. There is no problem of electromagnetic fields, and it is having the comparatively long life. Let's see disadvantages. The disadvantage is that the color and the contrast, if you see the LCD, those are different for different viewing angles. So in most of the TVs you might have seen that the picture is visible with good contrast only when you sit in front of that. When you move to the edges or on the left hand side and right hand side of the television, you are not able to see those characters clearly. So that issue is there in LCD, but further in IPS LCD and AMOLED, that effect you do not see. It has poor black generation whenever you want a dark image to be created on LCD. So it has a poor black color generated. In case of AMOLED, the black is the pure black, and that is the reason is that AMOLED consumes less power than the LCD. Moving ahead, it is having the fixed resolution. You cannot change the resolution. Then it is having low reliability. Low reliability in the sense, because of humidity and high temperature, you will see the generation of characters on the LCD display gets affected. It is very slow in operation as compared to AMOLED. And LCDs need some drive as well. Because of that drive, it makes it slow in operation. So that is the reason. Moving further, let's say applications. So applications are like it is used in thin film transistors as well as LCDs, then in some alphanumerical displays, backlighting systems. It is used in medical applications as well. So most of the devices which are having these actuator like a screen, those screen are made up of LCD mainly. So LCD monitors, cameras, smartphones, then thermometers, optical imaging. So these are all the applications of LCD. So in day-to-day life, you will see that. So in day-to-day life, LCDs are having the tremendous applications around us. So let's see the interfacing of LCD with Arduino Uno. So here one LCD is shown here. So this part is actually LCD. This is a casing, a plastic casing, black color, and it needs some mechanism. As I said, the driver circuit is needed, and these are the connection pins. You can see the connection pin is varying from ground, VCC, V0, then RS, RW, then enable pin. Then you can see DB0 to DB7. So that is what total 8 lines are there. Then this is LED plus and LED minus. You can, in most of the cases, it is also called as anode and cathode. And the ground and VCC are also called as, the VCC is also called as VDD, and ground is also called as VSS. So it varies from the company to company notation. Let's explain the connection diagram. This VCC is going to have it must be connected to a 5-volt supply, and the ground should be connected to the ground. So unless this is done, you cannot use the LCD. So in order to work LCD, you need to give a supply of 5 volt between, and the ground is to be connected here. Further, it is having a third pin as a V0. So we require one potential divider, so that a low voltage must be applied at this pin so that the characters becomes visible. This is the voltage that we said that to be applied between the two polarizer fields. So this voltage should be minimum. With this voltage, your characters will be printed on the screen. So if you make this voltage high, there you will not be able to see the characters on LCD. So you need to keep this voltage less. In case if you don't get any potential divider, try to have two resistors to be connected in series of 10K and 1K, where 10K will be connected to VCC in series with 1K, and another end of 1K will be connected to ground. The connection point of 10K and 1K will be connected to this pin as V0. As voltage across 1K will be given, so it is 1K divided by 1K plus 10K. So 1K divided by 11K is almost zero point 0.9 something. That if you calculate the voltage for 5 volt, it comes out to be 0.45 volt. So such lowest voltage is required to be given at this pin. Further, there is a pin given as a RS. This RS pin is used as a register select pin. So you are not able to access the registers of LCD unless this pin is connected. So this is to be driven with the help of the digital lines of Arduino Uno. So it will be connected to Arduino Uno digital line, this RS pin. Then with this RS, enable pin should be connected to the digital IO pin. So these two pins with data bus lines will be connected to uh, Arduino Uno pin. Then there is a RW pin. This pin stand for the read and write purpose. So it is actually active high for read operation and active low for write operation. When you want to write some data on the LCD, this pin must be grounded so that when you ground it, it gets active low. Active low in the sense it comes into the write mode and you are able to write the characters in the register cell, that is registers of LCD. So that gets displayed on LCD. Moving further, there are 8 lines given DB0 to DB7. Out of these 8 lines, as our LCD is 16 by 2, so for 16 different columns, it is enough to use the 4 data lines. So out of DB0 to DB7, we will generally prefer DB4 to DB7 to be used. Moving further, if you want a backlight to be turned on that LCD for night uses purpose, in that case, this LED plus and LED minus will be used, where LED plus will be connected to 5 volt and LED minus will be connected to ground. Nowadays, LED Plus comes with inbuilt 1K register. A surface mounting device is already implemented there. But on safer side, we can connect one resistor in series in this LED Plus. In many of the typical practical LCDs, you will see LED instead of LED Plus A is written over there, and instead of LED minus K is written over there. So it is anode and cathode. Moving further, so this is a typical connection diagram given here. This is interfaced in Tinkercad. You can see a breadboard is used and a 5 volt and ground is given over the breadboard. Moving further, you can see this VCC, that is ground, is connected to this ground, and this VCC is connected to this VCC. Then this V0 pin, that is what shown by the yellow wire, is connected to the center pin of the potentiometer. The extreme two pins, rightmost and leftmost pin of that potentiometer, is one is connected to VCC and another is connected to ground. So depending upon this knob selection, you have to select the low voltage so that voltage gets applied to the V0 and you are able to see the characters on this display. Okay, moving further, so now this is a software version. In case of green one, the character displayed are the black one. So the most of the we have done the practical, so we know that on LCD the characters are printed with the black color. So here it is printed by the white color. Moving further, you get that RS pin. That RS pin is connected to pin number 2. Then there is a WR bar pin that is connected to ground. Moving further is A0 E0 pin. E0 pin is connected to pin number 3 of your Arduino Uno. Then DB4 to DB7 are connected to pin number 4 to pin number 7 of Arduino Uno. Then LED plus is connected through one resistor to the 5 volt supply, and LED minus is connected to the ground. So this is a code. Let me explain this code. In order to get this LCD working over there, you require one library, and the name of library is liquid crystal.h. So include that library. First line is hash include liquid crystal.h. This library will be called. We need to create one object with a data type of this library. So we are using data type as a liquid crystal, and one object is created as LCD. Then in this LCD data type, this object is we are going to pass the parameters which are nothing but the connection pins of this LCD. So what pins we have used is that RS is used for pin number, is connected to pin number 2, E is connected to pin number 3, then pin number 4, 5, 6, 7 has DB4, DB5, DB6, DB7 connections. So we are going to tell Arduino Uno that at what pins the LCD is having the connection. Moving further, this is a void setup. It will be executed only once. So here we are going to tell Arduino Uno that LCD that we are using is having the 16 columns and the 2 rows. So first line is LCD.begin. In order to tell or initialization of LCD, that is 16 by 2. We want to tell Arduino Uno that I'm using 16 by 2 LCD. So we are initially printing whenever we are going to boot it. This code will be running, and the code is going to have the message that LCD.print welcome. So this by default message is created on the first line. In second case LCD dot set cursor 3 comma 1. So when you write 3 comma 1, you are going to select this first line is for the column and second is for the row. So in second row, the third column will be used to print the next character. next message, and that is LCD dot display hi students. I'm having the screenshot from some another project, and this message is not shown over there on the display. So you will be seeing welcome at the very first block, and the hi students will be printed on first, second, third here at the third column and the second row. So here you are going to see the hi student message over there. Moving further, we are going to use this loop, while loop, to run infinitely. So there I am calling a function, inbuilt function, lcd dot scroll display left. So you can see D and L are capital here. No parameter are passed inside this bracket. So it is going to make whatever the text is displayed on the screen, it is going to make that text to move on the left side continuously. It is going to rotate on the left side continuously, and we are having a delay of 100. In order to get character to be rotated on the right hand side, you can replace this command with lcd dot scroll display right, where R will be capital. So this is how we covered today the LCD and its Arduino Uno interfacing. Let's go to the second part, which is having the 7-segment display and its interfacing with the Arduino Uno. Moving further, this is a 7-segment display. The name 7-segment display comes the idea from the LED. The LED is having anode and cathode. You can see here, it is having total 8 LEDs connected over here. One, that is 1A has 1, 2, 3, 4, 5, 6, 7, and this dot. It is a decimal point dot. So that is what 8 LEDs are connected over there. If you see the BC, that is 7-segment display model, it looks something like this, and it has total 5 connections on the bottom side and 5 connections on top side. From bottom side, the leftmost pin is a pin number 1. So this is a pin number 1, this is pin number 2, pin number 3, pin number 4, pin number 5. Then on top continue the sequence as pin number 6, pin number 7, pin number 8, pin number 9, and this will be pin number 10 as the last. Remember, pin number 3 and pin number 8 is not connected, is not given any name. It is used to identify what connections to be given. If it is a common cathode, this pin number 3 and pin number 8 will be connected to ground, and if it is a common anode, this pin number 3 and pin number 8 will be connected to a 5-volt supply. You can see the pin number 1 is E means this LED segment, then pin number 2 is D, this LED segment, pin number 4 is C, that is this LED segment, and DP is this LED segment. Pin number 6 is B, that is this LED segment. Pin number 7 is A, that is this pin LED segment. Pin number 9 is F, that is this LED segment, and pin number 10 is G, that is this LED segment. So like this, we are having total 8 LED segments. So out of these LED segments, either their anode will be connected together or their cathode will be connected together. So remaining connections accordingly you are going to have. So these lines will be having the remaining lines. If it is a common cathode, then this pin number 3 and 8 will be having the common cathode. And then in that case, all these A, B, C, D, E, F, G and DP will be anode of the respective LEDs. So if you ground 3 and 8 in case of common cathode, then sending 1 on these lines is going to make particular LED turn on. In case of common anode, the pin number 3 and pin number 8 must be connected to VCC voltage as a 5 volt, and in that case the remaining lines, that is A, B, C, D, E, F, G and DP, will be the cathode of the respective LED. So you need to send 0 signal on these lines to make particular LED turn on. See here, this is a common cathode example given. So A is having this, like this design is there. So as it is a common cathode, the pin number 3, sorry, this pin number 3 and pin number 8 must be connected to the ground. So all the LEDs, their cathode is connected to pin number 3 and 8, and you are going to connect that together. So out of all these 8 LEDs, their cathode is connected together. So this is a common point of pin number 3 and 8, and this will be the respective A, B, C, D, E, F, G, H and D, DP. So like this, it will be the anode connections. So when you send 5 volt here, particular LED will turn on. You see, this is a drawback. Actually, there is a drawback because you have connected this to the ground, and every LED is going to consume a current. If you make all LEDs on, then there is an issue of the current sinking. In order to get rid of that, most of the time the common anode type of LED is preferred. In common anode type LED, already the care is taken that the enough voltage gets, enough power supply gets applied over here as a 5 volt. So in order to get particular LED turn on, you need to send a low signal on these lines. So sending low signal is not going to bother about the current sinking problem. So common anode LEDs, common anode type of 7 segment displays are preferred most over the common cathode type of 7 segment displays. If you want to have 7 segment displays more than one to be used in your application, you can get such type of module. So that module is having total 4 7 segment displays already mounted. It is typically used for the timer or watch applications. You can see the 2 decimal points are given over here, and these points are given over here. So particular segment gets activated depending upon your programming. So it has different lines, that is D1, D2, D3, D4. So depending upon D1, D2, D3, D4, a particular 7 segment display will get activated. So you can go with these modules in your application as well. This is given for just how to, you must have the knowledge what different kind of 7 segment displays are available in market. So moving further, the connections are explained in this PPT. As we know that pin number 1 is E, pin number 2 is D, pin number 4 is C, pin number 5 is DP. In same fashion, all pins are explained here. Pin number 3 and 8 in case of common cathode must be grounded. In case of common anode must be connected to VCC. And rest of the pins are to be connected to the digital pins of Arduino Uno. Moving further, this is a code that is going to explain the interfacing of this 7 segment display with Arduino Uno. I'm using Tinkercad for this design. So what is done here, the all pins are connected like this. The pin number 1 is going through like this. It is connected to different pins of your Arduino Uno. So I'm using to connect the, instead of using pin number 1 to pin number 10, I'm using like A, B, C, D characters as my reference. So A is connected to pin number 2 of Arduino, B is connected to pin number 3 of Arduino, C is connected to pin number 4, D to 5, E to 6, F to 7, G to 8. Okay, am not using DP, so that's why I just grounded the DP. So with pin number 3 and pin number 8, as I don't want to use any decimal point operation, as this is a single character to be displayed. So I have just grounded that with this ground. So pin number 3, pin number 8 and pin number 5, all three are grounded here as shown in the figure. And I'm using 1K resistor to be connected to the LED on safe side so that it will not get any problem in the working. So let's see the code. It is very, the circuit diagram I already explained. Let's go to the code. So initially I'm going to use the letters A, B, C, D, E, F, G with the pin numbers where it is connected. So where as A is connected to 2, B to 3, in same fashion I explained, G is connected to 8. Then void setup will be executed only once. In this I want to tell that this pin number 2 to pin number 8 are the output pins. So we are going pin mode, I'm going to use a command as a pin mode A comma output, again pin mode B comma output, and in same fashion it is written till pin mode G comma output. So all pins are given a direction of output. So on this, if high signal is sent, a particular LED segment will turn on, and the segment which will get 0 will be turn off. Like this, you can go on and generate the character. I have written the program for each character separately. So this code is to display 0. So void loop is going to display the character continuously. Fine. So initially what I'm sending here is that, let me see, from A to F I'm sending a high signal and sending low on G. So as G is here, if this is low means this will be off and rest of the all will be turn on. So it will show the character like a digit 0. So digit 0 will be printed. In same fashion, moving ahead, so this is used to display 1. In order to display 1, we need to print only, we need to send a high signal on B and C, and rest of all should be low. So you can check in the code, we are writing B and C as high and rest of all are written as a low. As a result, only B and C will glow and all LEDs will be, rest LEDs will be turned off. So one character will be printed on this LCD. Further, in order to print 2, you can get a logic in same fashion. 2 will come something like this. So in that case, F and C should be low and all other LEDs should be high. So like this code, the C is having low and F is having low, and all other LED segments are having the high signal sent on their anode. As a result, F and C will be off and all other LEDs will glow, and character 2 will be printed on the 7 segment display. Further, this is to print the character 3. In order to print the character 3, you can see F and E should be off. So here E and F are sent as a low, or the whether and all of the remaining A, B, C, D, G segments are sent high. As a result, F and E will be off and all other LEDs will be on, and you can see a character 3 printed over there. Moving further, in order to print 4, F, G, B and C should be high and all others should be low. That is A, E and D should be low. So here A is low, D is low, E is low. So this will print the character 4 or digit 4. And last, in order to print 5, you need to make B and E low. So as shown here, the B is low and E is low, and all other segments are sent high signal. That's why the character digit 5 will be printed over here. In same fashion, you can print the rest of the digits 6, 7, 8, 9, and also some alphabets you can print. So you need to write a code so that one by one 0 to 9 will be printed on this segment. So what you can do, in your code initially you can take a segment for this to display 0, give a delay of 600. After that, below that, copy this code which is for to display 1. Below that, copy the code for 2. Below that, copy the code for 3. In same fashion, you write code till 9, and you will be seeing that as this loop executes infinitely one by one sequentially. So initially on the segment, it will show 0, then 1, then 2, then 3, then it will go up to 9. Again, it will start from 0. Like this, it can be a counter from 0 to 9. It will be a simple decimal counter. By this logic, you can design it. There is an assignment, and the assignment is that you have to implement this code in the proteus. Okay, and this you have to display only 0 to 9 characters over there, 0 to 9 digits over there, and that proteus code with the snapshot of the result must be uploaded in your assignment. This is only the task. It is to be submitted till the Friday. Okay, I will give you the deadline. So get it designed and submit it. And this much there for today's lecture. Have a nice day. Thank you so much for coming attending this lecture.